before we get going on writing formulas and naming compounds, I want to show you that there's a document called Symbols to Memorize. It has the elements that you need to have memorized or have in your head. It also has the polyatomic ions and the common metal ions. And if you don't know these, it makes it a lot harder to do the next step in learning how to put them together. So I strongly suggest looking at those and having them in your head before you start trying to name compounds and write formulas. Okay, well, when we go to write formulas and name compounds, one thing we have to think about is that there are two different systems for doing that. And the division is on these main two types of compounds. There are molecular compounds and there are ionic compounds. And they're very different as far as their properties go. Molecular compounds are how we normally think of compounds being. They exist as molecules. That's a small group of atoms that are attached to each other. And if there is some attraction between molecules, it's relatively weak compared to what's holding that together. An ionic compound it's just like a big crystal, and the ions are all touching. You don't just have, like two that are together and kind of separate from the others. They're just all in a big crystal. And so when you have the formulas, the molecular ones, the formula, and so chemical formula is this, unlike a mathematical formula. The formula tells you what is in one molecule. In a ionic compound, the formula tells you the ratio of them. So it's not talking about these two because it's not like those two are separate. The NaCl, it tells you it's a 1-to-1 mole ratio between sodium and chloride. So to name and write formulas, you have to know which type of compound you have. And you can tell that from the name or formula because a molecular compound has nonmetals only. And we also call this type of compound covalent because they have covalent bonds. Okay, and then an ionic compound, they have a metal and a nonmetal. Or sometimes in place of the metal they have a polyatomic ion. So I'll just put if they contain a polyatomic ion. Then they are ionic, and that makes sense. Polyatomic ion, they're ionic. And so remember on the periodic table, there's a little division. And on the periodic table I do give you on tests, it has that little stair step written. And remember that over that are the nonmetals. And then all of this under it, these are all the metals. Remember that hydrogen is right here. It is a nonmetal as well. But anyway, so that's how you decide which category you're in. So let's look at how to write formulas for ionic compounds. First, you want to make sure that it's ionic. So we look for that metal and nonmetal. And in this compound, magnesium is definitely a metal, so with a nonmetal. Then we write down the symbols with the charges, positive ion first. So this is where we look on our periodic table and we get those predicted charges based on the column that the element is in. So this is what I'm talking about. We did this where we showed that these are +1, +2. This is earlier in the PowerPoint. So magnesium is in the +2 column. Chlorine is in the -1 column. So I'm going to put magnesium first, Positive always first. It'll always be the metal that's first because metals tend to lose electrons and they're on the left side of the periodic table. They form positive ions. So it'll always be metal then non-metal. Okay, once you figure out their charges and you have them in order, you need to figure out the subscripts. The subscripts are the numbers down here so that it's neutral overall. And so what I'm doing here is that this is magnesium, it's +2. And if I want it to be neutral overall, each chlorine is just -1. So I need 2 of the chlorines to make it work. And so I could just be looking at these and I see I need 2 chlorines. Now it's not incorrect to leave those charges up there, but sometimes we kind of rewrite it and clean it up. You don't have to have them up there. But that's the formula for magnesium chloride. And notice that the formula tells you the ratio of ions. Let's look at another one. Okay, when you see the Roman number here, that tells you the charge. You need to know your Roman numerals. It doesn't usually go beyond 6, but anyway, so that's a 4. Lead and sulfate. So I know this is ionic because when I see this 8 ending, I know that's a polyatomic ion, and so it has a polyatomic ion. It also has a metal, so that would tell me it's ionic. The lead, the charge is given. Lead is in the middle of the periodic table. It's not in one of those columns that we know. So that's why we have the charge given. And then sulfate is a polyatomic ion, and I can look up its charge if I need to. So if I bring their charges down, I see right now it's not neutral. And so there are different ways that I could try to fix that. Let's see what's correct. So I may do this. I see that I need more of the -2, so I'm just going to put a 2 here. And that's obviously not right because I don't need 42 oxygens. Okay, what else might people do? Sometimes people get to doing these and they kind of go a little overboard. And they do something like this. That is neutral, but that's not right because it's not the lowest whole number ratio. Okay, and so I can't do this. I need a parentheses because I can't have 42 there, so I'm going to end up like this. And that's correct. That is neutral overall. If we looked at those charges, we would have a total of -4 for the sulfate, 2 times -2, and a total of +4 for the lead.